Hi all, welcome back to my channel. I hope everyone is doing fine and everyone completed their respective task of the studies today and are doing study right now also. So this is day 111 of my GATE CS prep journey, and today I've studied for 11 hours of computer networks, digital logic and algorithms. So the new thing I'm started doing from today is CN I've already done. So I need to, like, before doing questions, I'll be doing questions on Friday, Saturday, Sunday. Till the Thursday, I'll be covering lectures and revision of computer network. And on all these 3 days, only question I'll be solving. So what I've done, I can show you the topic wise. Let me show you that. So if I go here, this is CN opened. Okay, I have added this only topic wise things, because what happens, when we sit for typical revision process, like we go from start, and usually what happens, like starting part is always covered or touched and we are very familiar with it. The later parts or topics are not that in contact uh, to study for that. So I've divided all the topics, and I'll be doing topic wise revision. Whatever I feel like, any topic I can pick, that way I'll be covering all the topic. And I mean, anytime sequential is going sequence wise would be great, but if not, you can pick any topic, and if it is not dependent on any other, then start doing it. You can also do this what do you call, practice of dividing topic and studying topic wise. So I started with IP addressing. IPv4 addressing is there. There is nothing like only 32-bit address, and total number of IP address in IPv4, that's only there in IPv4 addressing. Then there are a lot of things in classful addressing, like how to identify all the classes, ranges, percentage of like classes, percentage of IP addresses in classes, and questions. So I've done a little bit of that, but tomorrow my plan is I'll be starting with flow control, because I think that needs I need to do that or revision. So first thing I'm going to do tomorrow is CN, a flow control topic. Coming back to today, like regarding algorithm, I have again done this loop complexity, like it's completed PYQ part. There were like 4 to 5 PYQs, very in detail. I've covered that with my notes making, and it took like almost 6-7 hours to complete algorithms, one lecture and like 1.5 lecture from yesterday half, and today like it was 3 hours long lecture, so it took 5.5 hours to complete it with notes. And the third module I have started like recurrence relation in algorithm, like all the recurrence function. You need to find space complexity uh, through both the method, what do you call, stack method and recursion tree method. Just give me a sec, I'll show you that. Sorry for this. So this was the PYQ that I started yesterday, but I left in between, so I covered it today morning. What we need to do it, like, we need to find the time complexity only. You can see value of f of n, like first relation between two functions, asymptotic relation, then comparison between those, and then you can choose the options. Second also, this is the return value, means final value of function you need to find, and then for that everything you need to execute and see very small details. So this is the PYQ. We have already done it, like these kind of questions in previous lectures. So but still, I mean, there are a lot of things, like you need to pay attention while solving it, then you will get the answer, correct answer. um Yeah. So last question was this. It was very easy. It was only PYQ. Relation between best case, worst case, and average case. Algorithm. It is general. We already knew the like what is based. They have given the option, and from that you need to you know uh, eliminate it. So after that recurrence relation model 3 started, and I've completed one lecture from it, which was 3 hours long. It took, I think, total 6 hours to complete. Not 6, 5 hours it took. So you can see this is analyzing space complexity for recursive function or programs. What is recursion is like function call itself, it's recursion. And this technique is known as recursion. Used to solve problem by using smaller subproblem of same form. Suppose if you want to write, this is the example factorial of n, and these are the what do you call by there are few methods to solve it. Recursion tree method, and you can see after calling inner function you need to return value, like after once everything is completed execution, and while returning we'll return from bottom. So that's the recursion tree method. And method 2 is stack. So whenever the function gets called, each time activation record gets pushed into stack. So that's how, and you started popping out once it's done. Then stack spaces, maximum grow till 5 function, like in stack activation recorder, like it is growing till 5. So that's a space, you can say stack space. And for example, in the stack at a time you can store 5 function activation records. So stack space is depth of function call, and space is 5 function call into C. Space complexity for a fact of n. Depth. So this is decides space complexity. Depth is n function calls into n times function calls whenever fact function called, activation record of that fact function is pushed into stack. And activation record is constant, like it will take some constant space, that is C, that is n into C. And stack method space complexity. So again here stack method is used, the second method. Here example of Fibonacci series. Fibonacci series of number in which each number is the sum of two preceding number. Here also method 1 is recursion tree method, and these are the depth, you can see that I have level or depth, you can see. And all these are function calls, total 15 times function is getting called. And method 2 is stack method. Sorry, here for Fibonacci series, this is the proof actually they have given, like why stack space depends on depth of the recursion tree and not the total number of function calls. Stack space, depth of function call into space of each function call. So these you can consider only single stack space, okay? Because usually to see it for these, like how this works. If function 6 gets called, inner core like f of 5 will get call, and this will get called n-1 logic, and it will get written to above, like here f5 get call here, and then so for these f4, f3, f2, here's inside you can see all are getting called. That's why it's uh, drawn in grid method. So for inner function f2 and f1 call, the left side one is already getting called here, but right ones they are getting called, and that's why they're shown here. So that's a proof of this line basically. Maximum activation record in stack at some point equal to 5, and each activation record needs some space denoted by C. So 5 is depth function, depends function call 5, and C is some constant space. So the image I have shown is proof of this line. Stack space depends on depth of the recursion tree and not the total number of function calls. And stack space is depth of function call into space of each function call. That is stack space. So till here I have covered today regarding algorithm. And for digital logic, this is the lecture I've just started. Like regarding important mux problems in digital logics I have done today. Like from given expression or question, you need to find the correct option and you need to implement not gate using mux and get using mux. Here there is direct conclusion, right? To implement not and or 1 2 cross 1 mux required, and NAND and NOR 2 2 cross 1 mux required. Then there again are questions. So these were really good questions because you need to minimize the expression. So K-map comes into picture. I won't be like explaining each and every question in detail here because you can see, but different variety of questions are there. Like there are both control line are same, and here we need to find minimum time required to get y if all the input are present at t equal to 0. So if you see diagram, it will like at first there are no mux required. Like to get at y, it's directly coming here. So the case one is like propagation delay of 1 mux, that is 3 microsecond. And second, like not gate, and here you needed to find this output. So here not gate and mux is come. So not gate and 2 mux is coming. This is not gate, this 2 muxes. So 7 microsecond. So these are again questions. And this was the lecture I've just started, encoder, decoder, all the combinational circuits. So but I'll be continuing tomorrow. For now I'm done. And regarding CN, I have started with IPv4 addressing. I've done that. Flow control, I'll be doing it tomorrow. Sorry for this. Let me unlock it. IPv4 addressing I'm marking because it's done. And each like till week till Thursday we have allotted like 6 topic we can cover. That's the target, and then on 3 days we are going to do questions. You can see here 6 topics per week. That's all. I'll be doing flow control tomorrow because still like I'm familiar with this. I'll be starting like flow control first for CN. If I go back, let's see the digital logics progress. Okay, fine, there is no. So we are left with 220 days for gates, yes. So if you also want to study 10 hours or 10 plus hours till gate exam, I'm not saying only few some days, like till the time we are done with exam, if you want to study 10 plus hours, please uh, join this channel and subscribe to this channel to be consistent with me, and put your efforts. Let me know how many number of hours you guys are putting right now, and how you're distributing your hours. Like, are you watching lecture, are you practicing any questions? You can comment me down. And yeah, join this channel more. Like, it would be great if more people come and join this channel. So thank you all for watching and subscribing to my channel.